the Always Believe House. Oh, today we're going to talk about the key attributes of a quadratic function graph. And it is going to be another F-U-N, fun. So a magical whiteboard appears, and let's get rocking and rolling. Okay, let me get this over here. Here we go. The characteristics of a quadratic graph. Oh, A, quadratic equation. Is an equation that has a highest degree or highest exponent of 2. These are all examples of quadratic equations, okay? Then write this down. Standard form. Is y equals ax squared plus bx plus c. That's the standard form of the quadratic equation. So you go from the x squared term to the x to the constant. This c will be your y-intercept. Talk about that later today, okay? This right here is the parent function. Okay? Just like linear functions, quadratic functions have a parent function as well. The quadratic parent function is y equals x squared. The graph of any quadratic equation is called a parabola. It's not a parabola. Most people, first time they say it, would say parabola. It is called a parabola. A parabola is the basic study of calculus. Your cell phones, your computers would not operate without these parabolas. Basically, calculus is a study of motion along the parabola and the area above and below these curves. Very important stuff. What you're learning here, if you go into engineering, this is the base level of what your calculus will be, okay? Really important stuff. Now then, let's graph y equals x squared. On your calculator, it's going to be f of x equals x squared, okay? So go to your calculator. I'm going to clear mine, delete, hit enter, and then hit the tab button. And then I have f1x squared, or f1x, so I'm graphing a function, and then type in x, and then hit the squared button. The squared button's to the left of the 4, hit enter, and this is just like the picture we have, doesn't it? Okay? Just like the picture in there, okay? So, I'm going to kind of expand on this. Let's get the ordered pairs of this. Hit Control-T. Okay? Control-T, then hit the up arrow once to get to 0, 0. Do y'all see that? Or twice, really. On my, you can see 5 rows. You can only see 4 on your calculator, depending on what calculator you have. But this table right here is really important. And if I were to go up to -3, I would get 9, wouldn't I? Notice the numbers above the table are the same as below. That 0, 0 is the cutoff point. If you look right here, look at the y's in the table. They're 1, 4, 9, 16, 25, aren't they? Okay, let's write this table out on our paper. Okay, so write down x and y. Let's put -3 to +3. Okay, so -3, -2, -1, 0, 1, 2, 3. If I write down the y's from the table, I'm going to get 9, 4, 1, 0, 1, 4, 9. And if I were to do 4, I would get 16. These numbers are perfect squares, aren't they? Okay? So in a parent function, in your parent quadratic function, your y values will always be perfect squares. Because you're not changing, you're just doing x squared, okay? Also notice this table does not have a slope. It does not have a constant rate of change. As you go away from 0, the gap between the numbers gets bigger and bigger, it gets steeper. So as you go this way, up the curve, you get steeper as you go up the curve, okay? This bottom point right here, as we've already learned, is called the vertex, isn't it? That's a very important point. The vertex of the quadratic parent function is 0, 0, isn't it? Okay? A graph has 3 important characteristics. Its vertex, its axis of symmetry, and its zeros. Those are the important points of the graph. This activity is just to reinforce the vocab of this. You can be using the calculator, graphing the parabola, and getting the vertex, axis of symmetry, and the zeros. Okay, the vertex of the graph is the lowest or highest point. If it's the lowest, it's the min. If it's the highest, it's the max. If it's the lowest, it looks like this, doesn't it? If it's the max, it looks like this. Okay, so if it opens up, it has a bottom. If it opens down, it has a top, doesn't it? Okay, so the parabola will either have a bottom or a top. If it has a bottom, it's a minimum. If it has a top, it's a maximum. Okay, the axis of symmetry. Of a quadratic is a vertical line that cuts the parabola in half and it goes through the vertex. So let's say my vertex, let's just say it's x comma y. This number is going to be the axis of symmetry. It's going to be x equal whatever that number is, okay? So your axis of symmetry will take the parabola and it's going to cut it in half and it's going to go through the vertex, okay? That's what the axis of symmetry will look like. Lastly, very important points here. The zeros are where the parabola crosses the x-axis. In a table of values, the zeros are going to have 0 to the right, okay? If you input a number, you output a 0. That's why it is called a 0. It's also the x-intercept, right? Okay? And the 0 can have 1, 2, or no zeros, okay? We'll talk about that later. So the parabola can either have 1, 0, most likely it will have 2. If the parabola does not cross the x-axis, there are no zeros. So that's some basic vocab. Let's keep rocking and rolling. Oh. Turn the page. Okay. Now that we got some graphs, and we're just going to label it. These are like your notes in it. Okay, so plot the vertex and plot the zeros. Okay. The vertex is at -2, -4. That -2 is going to turn into your axis of symmetry. The -4 will either be your max or min, okay? Okay, because of parabola, the vertex, because that it is the highest point of the graph since a parabola opens up, okay? Okay, and it's also a max in it. Okay, the axis of symmetry, if you want, you could draw this dashed line, can't you? That's where it cuts the line in half. Notice it goes to the x-axis at -2. It's going to be x equal -2. That's the vertical line that cuts the parabola in half. And the zeros would be -4 and 0. Because that's where it crosses the x-axis, okay? If you wrote those as ordered pairs, it would be -4, 0 and 0, 0, right? Input -4, output 0. Input 0, output 0. That's why it's called a 0. Let's go to the next one. Okay, put a dot at the vertex, and we only have one intercept, right? If the vertex is on the x-axis, it has 1, 0. So my vertex is 2, 0. Remember, the 2 is going to turn into your axis of symmetry. The 0 is going to be the max or the min. On this instance, it's a min in it, because we have a bottom, right? Okay, because the lowest point of the graph, since a parabola opens up, okay? The axis of symmetry is going to be this dotted line, which is x equals 2, or it's -2 in it. I'm sorry about that. So your axis or your vertex is at -2, 0. Did that on purpose to see if you're paying attention. Teachers do that all the time. Okay, and the 0, it only has 1, and it's going to be at -2. If you wrote that as an ordered pair, it'd be -2, 0, wouldn't it? So if you input -2, you output 0. Ho, 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 ho. Well, let's keep going. Okay, on this problem here, the vertex is right here, and it's going to be at 2.5, 2. Okay, because it's the lowest point of the graph since a parabola opens up, okay, and it's also going to be a min in it. Now then, the axis of symmetry is going to be this in it. So it's going to be x equals 2.5. Okay, and you don't need this blank, okay? The 0, there is no 0, okay? There's no 0 because the line does not cross the x-axis. And you don't need this blank here, okay? Piece of cake. Oh. So you need to know what the vertex is. You need to know what the 0 is. You need to know that axis of symmetry. and also the y-intercept. We'll get into that later. Now then, let's go to your homework page. I'm not going to do all these. I'm just going to do a couple. This is very, very simple stuff you're doing here, okay? I'm going to do one of each. You can do the rest. You got to be using your calculator some. Okay, so let's go over here. Let's put a dot on the vertex and write down the order pair -3, -6. And then label your zeros. They're -5 and -1, aren't they? Okay, write the order pair of the vertex. It's going to be -3, -6. The axis of symmetry, draw it. It's going to be just like this. Write the equation. It's x equal -3. Remember, it's going to have the x in your vertex. Is there a maximum or minimum? Circle one of them. It's a minimum. And the minimum will be this number. Okay? What is the maximum or minimum point? It's -6, isn't it? What is the zero of the function? The zeros are at -5 and -1. How many x-intercepts are there? There's 2. What is the zero of the function? I guess you should put x-intercept. Okay, and the x-intercepts are -5 and -1. Ho, 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 ho. Okay, you should be able to do the rest of those on your own and go to the back page, okay? Now then, on this back page, we're going to kind of change these tables. These tables are really important that you can generate the tables, okay? Okay, so we have this equation. Okay, now then, we're going to graph the equation and get the order pairs. Now then, plot the vertex. The vertex would be at 2, 3, would it? Okay, 2, 3 needs to be in the middle of the table. So scratch these numbers out and put a 2 right here. And I know I'm going to have 2, 3. My x is 2 and my y is 3. That needs to be the middle of your table. Now then, go to your calculator, and it's -x². I'm going to hit Control-T, get rid of my table, delete, delete, delete. Think of a bad thought, delete everything. Now then, I'm going to go -x² plus 4x minus 1. So hit Tab, -x², is it plus 4x? Plus 4x minus 1, plus 4x minus 1. So I got the equation in the calculator, hit Enter. Now then, I want to duplicate this table, so hit Control-T. Notice that the 2 is 3 in it. That's going to be my vertex in it. I need 2 points above it and 2 points below it. So I need the 3 is this one right here. The 3 is 2 and the 4 is -1 in it. So I'm going to go to here. The 3 was 2 and the 4 was -1. And then I'm going to go back and you're going to see something. If I go up, the numbers repeat. Okay, so 0 is -1 and 1's 2, right? Okay, so 0 or 1 would be here. 1 would be 2. Let me change this. And 0 would be -1, wouldn't it? Okay. Also notice this number right here is going to be my y-intercept. Okay. The C term will be your y-intercept. But you're going to recreate this table and put the vertex in the middle. Notice on this problem, there's no zeros in the y, is there? So the zeros would be decimal answers, okay? Going to turn out to be square roots when we study this, okay? Write down the order pair of the vertex. It's at 2, 3. Draw the axis of symmetry. The axis of symmetry is right here. Write the equation of the axis of symmetry. It's x equals 2. Is there a max or a minimum point? There is a max, right? What is the max or minimum point? It's this number right here. It's 3 in it. What is a zero of the function? Let's just say 0.5. Or, I'm sorry. What is the zero of the function? Write down x-intercept. How many x-intercepts are there? 2. And just guess what they would be. Let's just use 0.5. 0.5 and that would be 3.5. Okay, somewhere between 0 and 1 and 3 and 4 is it's across the x-axis. We could get the exact value on the calculator, okay? I'm not going to do that. It'll too time consuming. I'm going to do one more with you with this table, okay? Let's go down and let's do number 9. Okay, number 9 we have x² minus 4x plus 5. Or let's do one with zeros. Let's do number 7. Number 7, I think, is going to have the zeros in there. Yeah, let's do number 7, okay? So on number 7, put a dot on the vertex, and that vertex is at 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So 2, 7 should be my vertex, okay? That number is going to go in the middle. Is that right? 1, 2? Okay, so scratch these out and put a 2 up here. So I want my vertex to be in the middle. Okay? So when you make the table, put the vertex in the middle. Alright? Now then, go to the calculator. Hit Control-T, get rid of the table. Hit Delete, Delete, Delete. This is kind of tedious to do this over and over. Then we're going to hit Tab. Remember, if it doesn't say F1X, you got to hit Menu 3-1, don't you? And then we're going to type in negative 2x squared plus 8x minus 1. Negative 2x squared minus 8x plus 1. Negative 2x squared minus 8x plus 8x minus 1. I did it backwards. So plus 8x minus 1. Don't listen to the teacher, right? Just do what you're supposed to. Negative 2x squared plus 8x minus 1. Just checking, that's it. Hit Enter. Right here, I'm going to hit Control-T and get my table, right? Control-T. And I want the 2 7s right there in it. That's the vertex in it, okay? So I want the 2, 7 to be in the middle, and then the 3 and the 4 are going to go to the right. So I'm going to put 3 and 4 over here, and then I'm going to put 5 and negative 1. 5 and negative 1. Somewhere between the 3 and the 4 is the 0 in it. Okay, we don't know what it is unless we trace to it. And we'll do that later. It's just too time consuming. Now then over here, the numbers are going to go in order. So 4, 3, 2, 1, 0, right? So let's go back to the table. And we need to go up, don't we, to the 0. Okay, so 0 is negative 1 and 1 is 5, right? Notice the numbers are repeating, right? Because it's symmetrical around the axis of symmetry. So I've generated my table from this. This would be my y-intercept. If there were a 0 in the y's, that would be your 0. Now then, let's go through here. Draw the vertex of the quadratic. We did that. The ordered pair is at 2, 7. Draw the axis of symmetry. It's right here. The equation is going to be x equals 2. Remember, this number is going to be your axis of symmetry. Is there a maximum or minimum? It has a top. It has a maximum. I'm just going to write down max. What is the maximum number? It's that number right there. It's the y of your vertex, which is 7. The 0 of the function is going to, let's just do 0.5s. So the 0 of the function is the x-intercept. Okay, how many x-intercepts are there? 2. And it's going to happen between 0, it's between 0 and 1 and 3 and 4, won't it? Okay, we don't know exactly what they are. Let's just put 0.5, okay? Any questions? Hopefully y'all can finish this up. This is going to be F-U-N, fun, fun, fun to finish. Just graph these up. If you need help, message your teacher. You obviously have to have a calculator to do this. Make sure you have a calculator. The calculator form in the beginning of the year modules, the calculator agreement form has how to get that calculator, okay? Going to have a calculator. Have a wonderful, wonderful day. Remember, you are amazing. You are created to do wonderful things, and you are awesome.